Percent solutions. Solution concentration can be expressed in other ways besides molarity. So sometimes solutions are expressed in relative percent concentration of solute to solvent. Percent weight to weight can be written like that, also known as mass percent. Percent weight to volume to volume are expressed as such. So mass percent is the number of grams of solute per 100 grams of solution. A solution with a concentration of 14% by mass has 14 grams of solute per 100 grams of solution. To calculate mass percent, you divide the mass of the solute by the mass of the solution, which is both solute plus solvent, and multiply by 100%. So calculate the mass percent of sodium chloride in a solution prepared by dissolving 50 grams of sodium chloride in 150 grams of water. So to do mass percent here, it's the mass of the solute divided by the mass of the solution. But the solution is actually the solute plus solvent. So when we put this into our equation, we have this is the solute and this is the solvent because this is more than that. So we have 50 grams of sodium chloride divided by the solution. So the solution would be the 150 plus the 50, which is 200. Because the solution as a whole has both parts. It has the solute and the solvent in it. So that's 50 divided by 200, and then you'd multiply by 100%. So doing this in the calculator, 50 divided by 200 gives us 0.25 or 25%. Okay, calculate the mass percent of lithium bromide in a solution prepared by dissolving 43.2 grams of lithium bromide in 153.2 grams of water. Go ahead and pause the video and work through this example. Okay, so we have the mass of the solute is 43.2 grams. And then the mass of the solution is both of these added together. So that's 43.2 plus 153.2. We get 196.4 grams. So when we divide these and multiply by 100%, we get 21.999, so 22%. And this could also be expressed as percent weight to weight. Percent weight to volume. So now we have the equation percent weight to volume is grams of solute over 100 mils of solution. So as an example, 25 grams in 100 mils of solution would be a 25% weight to volume solution. Because that would be 25 grams over the 100 mils of solution. How would you make a 10% weight to volume sucrose solution in a total volume of 5 mils? So 10% has to first be converted to a decimal because that would account for the 100 mils here. So we have 0.1 is equal to x is what we're trying to figure out over the 5 mils. So 5 times 0.1 equals 0.5. So we would do 0.5 grams in the 5 mils to get to the weight to volume of 10%. You are asked to prepare 100 mils of a 5% weight to volume sodium chloride solution. So this is going to be converted to a percentage, or sorry, a decimal. 0.05 is equal to x over 100 mils. And when we do the math here, 100 times 0.05 5 grams would be added. You're making an SDS page gel. In order to make the gel, you need a 10% weight to volume ammonium persulfate. How many grams will you need for a 1 ml solution? So we're trying to do a 0.1 because this is getting converted to a decimal. And we're going to set that equal to x over 1 ml. So 1 times 0.1 is just 0.1 grams. How much sucrose would you need to create to make a 20% weight to volume? So we're going to convert that to a decimal. X over 40 mils. So 40 times 0.2 is equal to 8. So we would add 8 grams. Percent volume to volume. So sometimes you're given volumes of 2 different solutions. So how would you make a 20% volume to volume glycerol solution in a total volume of 14 mils of water? So we have 20% that has to be converted to a decimal. So we have 0.2 equals x over 14. So 0.2 times 14, and we get 2.8 mils. So very similar math as before, except our units are going to be in mils because it's a volume to volume. Sometimes the molarity of a percent solution needs to be determined. So example, what is the molarity of a 2.5% weight to volume solution of sodium phosphate? So you'd use the percent solution equation to get to the mass, and then once you have the mass, you would use the molarity equation. So what is the molarity of a 40% weight to volume potassium chloride solution? Well, a 40% weight to volume potassium chloride solution is talking about 40 grams in 100 mils. So if we had 40 grams of KCl, we need to put this into the molarity equation. Molarity equals moles over liters. So this has to be converted to moles, and this has to be converted to liters. So once we do this, 40 grams of KCl, converting this to moles. One mole is equal to the calculated mass from the periodic table. Previously, we had 74.551 grams. So we're going to multiply across the top, divide away the bottom. We got 0.536 moles. Well, 0.65 moles. And this has to be converted to liters. So we have 100 mils. Mils is on the bottom, liters is on the top. 1 liter is equal to 1,000 mils, and we got 0.1 liters. So putting this all together, the moles is 0.5365, and the liters is 0.1. So we end up with 5.365 molar. All right, go ahead and pause the video and try to work through the next problem. Okay, so 25% weight to volume means that we're talking about 25 grams in 100 mils. So first, what we have to do is convert our grams to moles. One mole is equal to the calculated mass from the periodic table. Just going back to get that mass of NaCl, 58.443 grams. So now we're going to multiply across the top, divide away the bottom. 25 divided by 58.443 is 0.42, and we're going to round it to 8.428 moles. Now we already did convert 100 mils to a liter, so it's 0.1 liters. So putting this in the molarity equation, 0.428 moles over 0.1 liters. And we get 4.28 as our molarity.